Greetings and welcome to week 7. We are in the week of September 29th, and that means we're going to end the week in October. I do have a picture. If you note that image in the upper right hand corner, it might look familiar to you. That is the supermoon eclipse that we saw I guess what was that? Sunday night. We saw that Sunday night. So hopefully you got a chance to take a look at that. It was pretty cool. I did see it bright red before the eclipse started, and that was neat. All right, so please make sure that you do have your math notebook out and you're ready to take notes as you watch this recording. That's going to be to your advantage. When you take good notes, it's going to really help you when you go to do your assignments this week because you're going to have good notes and examples to refer back to that's going to be very similar to the graded assignments. So if you don't have a math notebook out, pause this recording and grab one now and join back in and take some notes. So we're going to start with a warm-up question. We've got a triangle with an exterior angle. We've got a triangle with an exterior angle, and your task is to find that missing angle that's labeled X there. So this angle right here, labeled X, we need to find that angle. So go ahead and solve that now. If you need some additional time, go ahead and click pause and then click play when you're ready to check your work with mine. All right, so last week we learned about the exterior angle theorem and the pattern that exists with two of the angles that are non-adjacent to that exterior angle in the triangle. So when I say non-adjacent to the exterior angle, this angle right here that I just labeled in purple, that is an angle that is adjacent to the exterior angle. So these two angles are adjacent. To use the exterior angle theorem, we want to focus on the exterior angle, as well as the two angles that are within or internal angles of the triangle that are not adjacent. So I've tried to circle the angles that we're referring to in green here. And these angles all have a pattern. If we add the two interior angles up together, they're going to give us the sum. The sum is going to be the exterior angle. Aha, pretty cool pattern there. So to find the measurement of angle X, we're just going to add the angle 72 and 45 degrees together. So again, it only works when you add the two angles that are non-adjacent to the exterior angle. So we don't want to use this angle right. Let me get my pointer out. It's going to be, we do not want to use this one. The exterior angle is going to be the sum of the two internal angles that are non-adjacent, that are opposite to that. So we add these two up and we get this measurement. So 72 plus 45, let's go ahead and add that up, 72 plus 45, and we get, dun, 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 a total of 117 degrees. So the angle that we were looking for is 117 degrees, the measurement of angle X. All right, so let's move along here. Some reminders for this week. Just a reminder that I did put that website on the top of the updates page that has a list of the postulates, theorems, and definitions that we're learning from here on out. So I kept that up at the top so that you can refer back to it. Check it out. Make sure you're taking notes. Again, taking notes while you're going through the lessons, taking notes while you're watching this recorded session. These are only going to help you, so please take notes. And then last but not least, be patient when you submit late work or redos. I've mentioned this before, but I'm still getting emails that are saying you haven't graded this or you need to grade this as soon as possible. Again, my policy is that my priority is to grade the current work first. And then I go back and grade redos and submit late works. And remember, there's a lot of students that I have to grade late work for and redos. So please be patient. I will get to yours. And with the late work, same thing is true. So to get your work graded the fastest, make sure you're turning your work in on time. All right, so week 7, we are going to be focusing on triangles this week and how we can prove that triangles are congruent. So we're going to be doing Unit 2, Session 5 and Unit 2, Session 6. We also have a special date this week, October 1st. This is our count day for how we get funding for our school. So it's so important that you guys are logging on to all your classes on October 1st and also completing assignments. So this is super important. So the earlier you can log on October 1st, which it happens to be Thursday this week, the earlier you can log on, the better. If you do not log on earlier on in the day, you're probably going to get some phone calls from the office just reminding you to do that because it is an important date for us to get our funding and so that we can continue to offer this program of that we are offering now. So I do have a special assignment to be completed on October 1st. It's kind of a different fun type of assignment where we're going to look at angles and a peace sign. And you can find that in the units folder. So just make sure that you're completing this assignment on October 1st, Thursday. All right, so we are focusing on triangles this week and how we can prove that triangles are congruent. But first, let's review what that means when I say proving triangles are congruent. So in order for triangles to be congruent, they have to have the exact same shape and the exact same size. So in order to have the exact same size, that means that all the angle measures have to be the same and all the segments or the side lengths have to be the same. So really what we're saying is that all corresponding, and remember corresponding means that they're located in the same position. So all corresponding sides and angles have to be congruent to give that shape the same shape, the triangle the same shape and the same size. So again, when we talk about corresponding, it means located in the same position. So angle side, segment, side QR is corresponding to X, Y on this other triangle. And remember these little ticks here, see how there's one little tick here and one tick on that side of the corresponding side? That lets us know that those sides are congruent. If we look at our hypotenuse, we can see that there's also 2 ticks on those, and that lets us know that the sides, QS is equal to side XZ. So remember those little ticks help us to know that the sides are congruent. So just a review about that. All right, so this week we're going to focus on proving triangles are congruent. So when 2 triangles are congruent, there's actually 6 facts that are true about the triangles, and we talked a little bit about those. We're going to have 3 sets of congruent sides, as well as 3 sets of congruent angles. And we just talked about that. So all 6 of these things, so each corresponding side are going to be equal, as well as the corresponding angles for each of those. So when we add those up, those are 6 things. The same is true with the angles. If you look there, there's 2 little arcs, and the corresponding angle on this side also has 2 little arcs. That lets us know that those 2 angles are congruent. Here we see there's 1 arc and 1 arc here. That lets us know that angle D and angle A are congruent. So the same thing that's true with the ticks on the side lengths is true with the angles. So 6 things are true when we have congruent triangles. That's a lot of things. But, and 6 facts to show, so just what we talked about, our 6 our corresponding sides, 3 sets of those, and 3 sets of corresponding angles. So 6 facts for every set of congruent triangles. Fortunately, this is really cool. When we need to prove or show that triangles are congruent, so read down here with me, we do not need to show that all 6 facts are true. So that is some good news. There's certain combinations of facts that are sufficient to prove that angles are congruent. And these combinations of facts guarantee that if a triangle can be drawn with that information, it will take only on one shape. So we're going to learn about the combinations that we can use so that we don't have to go through and prove that all 3 corresponding sides are congruent and all 3 corresponding angles are congruent. We're going to learn some shortcuts. So here's the methods for proving that triangles are congruent. So I'm going to go through these first a little quickly, and then we're going to talk about them one-on-one in more detail here. So we can use, and this is what you're going to be focusing on this week, if you can show that the 3 sides of one triangle are congruent to the 3 sides of another triangle, we can prove then that the triangles are congruent. So using the side, we abbreviate it with SSS. So if we can prove that 3 sides of one triangle are congruent to the 3 corresponding sides of the other triangle, we can prove they're congruent. Another way that we can do it is if we can prove that 2 sides and an included angle, and I'll talk about that in a moment here, what I mean by included angle. So if we can prove that 2 sides and the included angle are congruent to the corresponding parts of another triangle, then we can prove the 2 triangles are congruent. ASA, that stands for angle, side, angle. So if 2 angles and the included side of one triangle are congruent to the corresponding parts of another triangle, we can prove they're congruent. Again, I'm going to talk about these more in detail, but I just want to introduce those 1, 2, 3, 4, 5 ways. Angle, angle, side. So if 2 angles and the non-included side of one angle are congruent to the corresponding parts of another triangle, then we can prove that the 2 triangles are congruent. And then hypotenuse and leg. So this HL only works for right triangles only. So you have to have a right angle in your triangles for this one to be able to use this one. So the hypotenuse leg we can only use with right triangles. So if we can prove that the hypotenuses are congruent and then the leg of our triangles are congruent, the corresponding legs are congruent, then we can prove that the 2 triangles are congruent. So the only one that only has 2 pieces that we can use is the hypotenuse leg, and we can only use that with right triangles. So let's talk about these more in depth now. Side, side, side. Alrighty. So if we can prove that the corresponding sides, so all 3 sides, if we can prove the corresponding sides, I'm trying to highlight the corresponding ones so that you can visually see that a little bit better. If we can prove that all the corresponding sides are congruent, then we've just proven that the 2 triangles are congruent. So that's the side, side, sides. So make sure you copy that one down. Alrighty. Side, angle, side. And remember, we talked about, on the other side slide it said included angle. See how angle is in between the side and side, it's sandwiched in there. We've got side, angle, side, where the angle is sandwiched between the S and the S. That is very important. That's what we say, that's what we mean when we say included angle. It means it has to be within or sandwiched between the 2 sides. So let's take a look at what I mean here. So we've got side, angle, side. So here's the corresponding sides that are congruent. And then let's do our other set of sides. These sides right here are congruent, they're corresponding. And then look very carefully how the angle is sandwiched in between those 2 sides. Do you see how the angle is sandwiched in between there? the angle that we're referring to is not this one up here that would not be sandwiched between our corresponding sides. It's sandwiched right between. So we've got side, angle, side. That is really important when we use the side, angle, side, that angle is sandwiched in between there. And that's what we mean when we say included angle. So look over here on the right at these two triangles. So look at these set of, here's our angle. And then the only two side lengths that we're given to use to know that the two angle sides are congruent. So we've got this side is labeled 5 centimeters as well as this one. So we know those are congruent sides. And then the other set, the pair of labeled sides is this 8 centimeter and this 8 centimeter. But look at where the angle is. So we've got angle, side, side. We don't have the angle sandwiched between our two corresponding sides. See how it's not sandwiched between the highlighted sides, which are the only two that we can say are congruent because they're the only two sides with given lengths. This side here, we don't know if they're congruent. We don't know. But this angle is not included. It's not sandwiched between the sides. So this is not going to work. We could not use the side, angle, side for the two triangles on the right here. Alrighty, so let's move on. Angle, side, angle. And again, we have to have the side has to be sandwiched between the two angles. And look at, see how we've got the corresponding sides here? We know they're congruent because of that little tick in there. And then we've got our sets of corresponding angles. One tick or one arc here, one arc here. And then let's go ahead and highlight the others. 2 arcs here and 2 arcs here. Notice that we've got an angle. I'll get my pointer out again. An angle, that side is sandwiched between the two angles. So see how the order is important here? Angle, side, angle. The angle with the sandwich side. And if we can use that, if we can find that pattern, we can prove that two triangles are congruent. The last one we're going to look at is angle, angle, side. Angle, angle, side. So see how we go angle, angle, side. Angle, angle, side. Angle, angle, side. So order is really important when we're using these postulates to help us prove that triangles are congruent. So let's review all of them that we just learned. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. So again, the order is so important. I cannot stress enough how important the order is, and that if you, to make sure that if you need a included angle or an included side, that it's sandwiched between the correct other sides or other angles. Notice we did not use side, side angle or this bad word ASS. So there's no such thing as these two postulates. There are only these 4 that we learned about. And we'll talk about the hypotenuse leg in just a moment here. I know we left that out. But let's get some practice with these 4 that we just talked about. So let's look at a bunch of different triangles here and see which postulate that we just learned about that we can use to prove that the two triangles are congruent. So I'm just going to number these so we know which one we're talking about. So number one, which postulate that can we use up here that I've listed the 4 we learned about to prove that these two triangles are congruent? So we've got one set of congruent legs, we've got 2 sets of congruent legs, and look at this leg here. That leg is being used for both of those triangles, which means we know that this leg has to have the same length because it's being used for both triangles. So if we really wanted, we could like put ticks in there, but we don't need to do that because that leg is being shared. So what postulate did we just use to prove these two triangles are congruent? If you said side, 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 you are correct. We did side, side, side. Good. Look at number 2. Look at number 2. We've got a set of corresponding legs. Get my pointer out. with 1 tick, so we know these 2 legs are congruent. We've got 2 ticks and 2 ticks, so we know these 2 legs are congruent. Is that all we know? What did we learn about vertical angles? Here's a set of vertical angles. Remember, we learned that vertical angles are gonna be congruent. So now I've got the angle marked in there. So now that I've marked that angle in there, what postulate can we use? Well, we've got a side, an angle, and a side. So it's really important that we are noticing that that angle is sandwiched between those 2 sides. So it's going to be side, angle, side. It would not be angle, or it would not be angle, angle, side. It's going to be side, angle, side. Good. Side with our sandwiched angle and side. We'll do one more on this slide and then we're going to move on. Look at the next triangle, see if you can't figure that out one on your own. I'm going to give you a moment. All right, so corresponding angles, corresponding sides, and then corresponding angles with a side that's sandwiched between our 2 corresponding angles. So that means that would be angle, angle, side, angle, because that side is sandwiched between the 2 angles. Good. All righty, so let's move on. Let's do this one over here. We'll call this number 1. Let's focus on the triangles on the right. So let's do one more practice. So see if you can look at this and figure out which postulate we would use. Alrighty. So we've got side, side. These 2 are congruent. Then we've got our congruent angles and our another set of congruent angles. So we've got side, angle, angle. Side, angle, angle. Side, angle, angle. So we would have to reverse that, right? Because there's no side, angle, angle. It's just angle, angle, side. If I go reverse there, I could say angle, angle, side. Good. Angle, angle, side. Awesome. Good. So lots of practice. I know we've got a lot in there. One more way is the hypotenuse leg theorem. And remember, the only way that we can use this is if we're dealing with a right triangle. We're dealing with a right triangle. And that is that we're going to, if we've got a right angle, see these right angles, we can use a hypotenuse leg theorem. So the hypotenuse has to be congruent, and then one of the other legs, one of the other corresponding legs has to be congruent. And that's the hypotenuse leg. So here, can we use the hypotenuse leg theorem to prove that triangle ABD is congruent to ACD? Well, first, I see these little squares that lets us know we're dealing with a right triangle, so that's good. We see that our hypotenuses are congruent. And then are we shown that another leg is congruent? We are. Remember, if you have a shared leg, like this leg right here, it's shared in both of the triangles, we just can assume that that leg is congruent because it's the same leg. So those are congruent. So yes, we can use the HL here, hypotenuse leg. Alrighty, so I'm going to stop things here, and that's going to be a wrap, and we're ready for our key phrase assignment. I'm going to have 2 questions here. Does order, we talked about order like with included angles and included sides. Does order, let me start over. Does order matter when we use the angle side angle theorem? So does it matter where the side is really what I'm getting at there. The side, does it matter where the side is, and where does the side need to be? So really, I guess what I'm asking is, where does the side, the corresponding congruent side need to be when using the angle side angle theorem. So I kind of worded that silly the first time, but really what I'm trying to get at here, and I'm only going to ask that one question, what I'm getting at is where does that side need? So when we're using the angle side angle theorem, where does that side length need to be? And what I'm getting at here is does order matter? And we talked about included side. So when we see this postulate defined, it's going to say that the side needs to be included between the angles. And what does that mean? So elaborate on that for me. And that's it. Have a wonderful week, and let me know if you've got any questions.